We're looking at question 1 from problem set 8, and this is a problem building a multiple regression model to try and understand what factors contribute to an NHL player's performance. And of course, this kind of information could be used to make better trades, ensure higher salaries were paid only to performers. So we got the information from the NHL website, and we got 199 randomly chosen players. We got information about the points earned as being a measure of their performance. And then we picked 6 factors, and we call those independent variables in a multiple regression model. And we wanted to know if any of those factors had a relationship with the points earned by a player. So our dependent variable is the points earned by a particular NHL player, so that's a dependent variable, and these are the independent, or the factors. We're looking to see if any of these independent variables can explain the number of points that are earned by a particular NHL player. So we got the information from the 2007 and 2008 NHL season. And the first thing we want to do when we build a regression model, a linear regression model, is we want to see whether it's appropriate. So we're going to answer this part of the question, part A, and we want to know whether it's appropriate by referring to the appropriate SPSS output. Now, the output that we look at are scatter plots of each of the independent variables with the dependent variable. And we look at these scatter plots. So we'll look at this first one. So the first one is for the age of the player, and we've plotted that with the points earned, so that's our Y variable, and that's X1. And each of these points represents a particular observation from our data set, a particular NHL player for the 2007-8 season. So we can pick out one point, and we can see here this player was about 32 and 32, and they earned about 50 points during that season, NHL season. So we look at the scatter plot and we want to ask, is there a linear relationship with the age of the player and the points earned? And we see that the points are quite scattered, and there may or may not be a relationship, but there's definitely not a pattern of a curve or an exponential function. So we'll say that there might be, and we can then look and see that I've got a fitted line here. So that's the simple linear regression line fitted to this particular variable. And we see it's going upwards, so that means it's a positive relationship. And it's, as I said, it's a very scattered collection of points of the age of the player with the points earned. So that would indicate it's a weak relationship, and we can further establish if it's weak or not by looking at this R squared. So that's only 0.7% of the variability of the points earned is explained by the variability of the age of the player. So this is a very weak positive linear relationship. And we also want to look and see if there's any outliers on a scatter plot. And in this case, we don't see much evidence of extreme outliers, perhaps a few here, but these, again, because there is more than one of them, they're not really considered to be outliers, and in the intro course we wouldn't be too terribly concerned with those. So we'll say there is not. And we can do this for every one of our independent variables. So if we look at salary, we would expect that players who earned more points would be paid more. And of course on the scatter plot we see that this is definitely the case. We do see an upward movement of the points earned when the salary goes up, so people who are earning more points make more money. So that would be a very obvious relationship in the NHL or any sports franchise. So we do see that there is definitely a linear relationship. It's not exponential, it's not curve, there's no curve, and it is positive because it is going upwards. And we look at this R squared value and we see it's a very large amount of variability of the points earned is explained by the variability of the salary. So this is a very strong relationship. So this is a strong relationship. And are there any outliers? Well, in this case, I don't see anything that would be obviously considered an outlier, so I'll say no, there is not. Look at the next one, which is the weight. So the weight of the player, we see again fairly random scattering of points that doesn't have a curve, may or may not be linear, so we'll say maybe here. And it's very weak. Our R squared is 1.5%, so very weak. The line in this case is going downwards. So the simple linear line that I fit on the scatter plot is indicating that it's a negative linear relationship if it is even a significant relationship, and we'll find that out when we conduct further tests later on with the questions. So for now we'll say it's a very weak negative linear relationship. There doesn't seem to be any obvious outliers, so no for the outliers. The number of games played by a player and the number of points earned, there is an intuitively obvious relationship. You can't earn points if you're not playing. So we do see here that it's a very strong relationship. Strong we see with the R squared, so this R squared value is very high, so that's indicating a very strong relationship. We see that the season ends. There's only a finite number of games per season, so the data set doesn't have any points beyond the number of games in that season. Is there a linear relationship in this case? Well, we do see that there might be evidence of an exponential type of relationship. So we'll say maybe, and in a further course on regression, you would learn how to model those type of relationships. For now, we'll just leave it as a positive relationship. So again, our line that's been fit for the simple linear model is going upwards, so it's positive, and it seems to be a very strong positive relationship. And are there outliers? Well, we do have maybe one here, so maybe there are some outliers that would affect this data set. And should we include this in a multiple regression model? Well, in this intro to multiple regression in an intro stats course, we would say that this is a good candidate for a factor that would help explain the points earned. The number of penalty minutes earned by a player, well, we'll see in this particular scatter plot, we've got, again, quite a random scattering of points, definitely an outlier. So there is definitely some outlier. One player in particular got a lot of penalty minutes and very few points. So is there a linear relationship in this case? Well, there doesn't seem to be any other type of relationship, or perhaps any relationship, so there might be a linear relationship. Is it a positive or a negative one? Well, our line is going upwards, so it's a positive. And again, our R squared is indicating that this is a weak relationship, a very small R squared value for this variable penalty minutes. Let me pick another variable, an independent variable, and that is the team point. So the number of points earned by the team, and we plot that against the number of points earned by a particular player. So in this particular case, we see the values are really widely dispersed. We maybe have some outliers here, so there may be some outliers. Is there a linear relationship? Maybe. It doesn't look like there's a curve. It doesn't look like there's an exponential relationship. The line is going downwards for this plot, so it's a negative relationship, and our R squared value is indicating it's quite weak. So when we go back and answer this question, we've looked at all the scatter plots, so we've evaluated all of them, and we would say yes. We might not have significant relationships, and we'll find that out in the next question. But for now, we'll say yes, it is appropriate, and we've evaluated all of the scatter plots. So we need to do that for each independent variable that we're looking at, and when building a multiple regression model, we need to look at whether or not there's linear relationships with all of them. And we do that by looking at scatter plots for each of the variables with the dependent variable, and that tells us whether or not there is evidence of a linear relationship. So the next part will be looking at part B and looking at testing these variables in particular to see if they are significantly related.